Find the value of the radius of the circle whose equation is given. The standard form of equation of a circle is shown. That is the sum of the square of x minus g and the square of y minus f equals the square of r. We call it equation 1. The center of the circle is at g and f. These are the values of x and y. Given that, the sum of 3 times x squared, 3 times y squared, 6 times x minus 12 times y plus 6 equals 0. Divide the equation by 3. It implies that the sum of x squared y squared, 2 times x minus 4 times y plus 2 equals 0. To find the coordinate of the center G and F, we compare the terms of the expanded form of equation 1 to the given equation. That is, negative 2 times g times x equals 2 times x. Then, divide the equation by negative 2 times x. It implies that g equals negative 1. It means that negative 2 times f times y equals negative 4 times y. Then, divide the equation by negative 2 times y. Thus, f equals 2. Therefore, the coordinate of the center of the circle, g and f, equals negative 1 and 2. From the given equation, the simplified constant term, c equals 2. Using the relationship, the constant term, c equals the sum of g squared and f squared minus r squared, we can find the value of r. Substitute values. It signify that 2 equals the sum of the square of negative 1 and the square of 2 minus the square of r. Make the square of r the subject of the formula. We have that r squared equals 3, after simplification of substituted values. Take the square root of the equation. It implies that r equals the square root of 3 in units. Therefore, the correct option is B.